Next question. Don't like, don't subscribe, don't give me credits when if I don't deserve the credits. But if you think I do deserve the credits, then you can share, you can like, send me the question, feel free anytime. Let's go to the question. Yeah, let's go to the question. So the question says, here it is. Everybody can see that, and let's see how we can get the optimum solution, how we can get the distinction. In the year 2000, the population of the world, 2000, that about 17 years ago, 17 years ago, this 2018, so 18 years ago. So the population of the world was 6.1 billion. The doubling time of the world population, 20 years. Whew, in 20 years time, excuse me, no, I don't get that one. They say the double time of the world population, 20 years. In which year would the population reach 100 billion if it continued to grow in the same rate? You need to use a calculator. Let's go. We need to use a calculator, right? But we don't want to use now. Okay, let's go to the question straight. Don't waste the time. Okay, so now this type of question, the exponential growth. This exponential growth question. Most of the population question is exponential growth question. So let's see how we solve this. Okay. Solution. So exponential growth question, exponential growth equation that we're gonna have to use. Solution. I always say n equal to means number or population final after 10 years, 20 years. I don't know for how long it might take. For now, this is population initial, when the population started. Population final, population initial, and they write your exponential. There's an equal sign here between the exponential. K is a constant times t. T means how long, how many years, how long. Okay, so let's plug in what we have. So we're going to split this question into two parts. Let me show you how to read the question clearly. In the year 2000, 2000 means initially, now you start. Let's say this is 2000. The population of the world was 6.1 billion. Do you think it's initial or final? They say year 2000, 2000 means now you start. Now we don't have any time. So initial, it was 6.1 billion when you started. You see what I'm saying? And then the doubling time of the population, 20 years. Excuse me. So, and then, excuse me, so we're gonna say if the doubling time of population 20 years means our time for now 20 years, so our time is 20 years. Okay, so if this is 6.1, so doubling means it's gonna be 6.1 times 2. So what do we have here? We have initial 6.1 billion and final, because they say doubling time. And our time is 20 years. So the only data that we don't have here is K. T is 20 years, N is 6.1 billion, and not 2 times 6.1 billion. So for now I'm going to say okay. So what is N naught? Also okay. So if this is X, this must be 2X. So I'm going to say if this is 6.1 billion, and this must be 2 times 6.1 billion, because it's doubling up. And they have our EK. We don't know K, but the time is 20 years. Remember this is a power. K times 20 is a power. Okay. Excuse me, so now I'm going to divide by 6.1 throughout, divided by 6.1. This and this cancel, and this cancel. We have a 2 equal to E, and they have a K times 20. So on the previous question I said whenever you have a unknown exponential, the value of E is known. If you take your calculator, plug in E, you're going to get 2 point something. E is 2 point something. So we know the value of E is like a normal number. And then exponential is unknown because it's K20. So whenever exponentials are known, apply log. This is very important. Very, very important. When your exponential unknown, apply log. You see, when the power is unknown, you see that power here? When it's unknown, always apply log. When you see, but make sure it's simplified. Your term has to be simplified. Like for example, if somebody give you 7 equal to 2 power t, you see, means 7 equal to, it has to be simplified in this form. Like when you see, so my exponential, my power is unknown, and then we apply log throughout. So same here, I have a E2. E is a number. If you plug in the calculator, it's going to give you 2 point something. So I have a 2 point power 20k. Let me write again so that you can see. It's like we have a 2. Everybody can see there. 2 equal to E, and then k times 20 is like 20k. So you see, our power is unknown. So apply log throughout. So say log or ln. Log is for high school. Like even this is high school, but I prefer ln. So you're gonna say ln of 2 equal ln of E. We apply throughout this side and this side before the numbers here, and then you say 20k. So what happened? Okay, what happened? Take this the power back. So you take this power behind the ln. So I'm gonna have a ln. So I'm gonna have a ln of 2 equal to 20k ln of E, but not ln of E equal to 1. Ln of E equal to 1. Ln of that one has to memorize. Ln of E equal to 1. Even if you plug your calculator, is gonna give you 1. Okay, so now we continue. We have a, so this one here is gonna be equal to 1. So we only have a ln of 2 equal to 20k. That's what we left. Ln of E, ln of 2 equal to 20k. So I can get my k there. Excuse me. So ln of 2 equal to 20k. Ln of 2 equal to 20k. So I want to get k. So I can divide by 20. Divide by 20 throughout this and this concept. So my k equal to ln of 2 over 20. So that's my k here. That's my k. Now, so I have the value of k. So now we continue reading the question. The question is not done. They say, in which year will the world population reach 1 billion? So now, we got k. Now we're gonna start to solve again question. Like we start afresh, not afresh, but it's like new pattern now. In which year will the world population reach 1 billion? So now we have a new final population. Okay, so we're gonna rewrite our population exponential equation. Population equation. Population exponential growth formula. So apply exponential growth formula. Exponential growth formula. Formula which is a n equal to and not E kt. So now it's gonna reach 1 billion, so 100 billion. But initially we know 6.1. We have our E k. We have a k now, so we know the value of k. This one here. So we say ln, put small bracket, ln of 2 over 20 times k. So now we're looking for times t, my apology, because now t is the one which you don't have. K we have. So now we're looking for t, that's all. So what we're going to do here, I'll say 100 divided by 6.1 equal to E ln of 2, 20 times k. 100 divided by 6.1, I can either change or I can leave it how it is, no problem. So say, excuse me, 100 divided by 6.1, put in the calculator, 100 divided by 6.1, okay, leave it for now. So we want to get what? K. So we say, I can apply ln throughout. So I'm going to say ln, because why apply ln? Because my power is unknown. See, so I'm going to say ln of 100 over 6.1 equal to ln of E, and then have a k. I can write k before, prior to ln of 2 over 20. Same thing, doesn't make a difference. And then what happened? I'll take this behind, always. Whenever I have a power, we take it behind the ln. Ln of 100 over 6.1 equal to k ln over 2 over 20 times ln of E. But we know ln of E equal to 1. Ln of E equal to 1. Ln of E equal to 1. So for that case now, we're left with ln of 100 over 6.1 equal to k ln of 2 over 20. So we want to get k. So how are we going to get k? Divide by all of this throughout. Divide by all this throughout. So divide by ln of 2 over 20 divided by ln of 2 over 20. So this and this cancel. So k equal. Okay, so we plug that in a calculator. Excuse me. Plug that in a calculator. Excuse me. So plug in the calculator quick. Man, this is a lot of 20, man. So plug in the calculator, or I could say this is like a fraction, so this one can go up. But it's not necessary to show there. But you know, sometimes you want to show how you get your stuff, so it's okay. So this one could come there, so it's 20. So it's 20. Ln of 100 over 6.1 over ln of 2 equal to k. So plug this in the calculator, insert that value in the calculator. So k equal no, mate, it's not k, man. What you doing here? Excuse me. T use our pen, man, because when you knew the value of k, the value of k was this one, so it's not is k times, so k, we had this k, so this is t by topology, this is t, 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 and this is t. Thank you for your patient understanding, and you're your patient. Okay, this is t times. Okay, so what is the time? Plug in the calculator, get time here. What time is 18.700 here. So what does that mean? If we started 2000, means when the population is going to be 100 million. So if we started 2000, so I'm going to write here. If we start 2000, if it was 6.1 2000, year of 2000, 6.1 billion. So for this population to become 100 billion, if I'm not mistaken, I think they say 100 billion, means 2000. The question is done, after time it has to take 80, but I just want to show you. Means if this is 2000, means 2080 years, means you have to say 2000 plus these years, which is going to be 2080.7. But if you approximate, it's going to be 2080.81. Means if you say 7 months or 0.7, it's not 7 months. 0.7 means like almost a year. So for population to become 1,000 million means after 80 years. That's how the population could be. Probably dead already at that time, man. Hey, I'm telling you, man. We're gonna be reading the history book like, man, this guy he was on YouTube, man. He used to have some guys who say I have a problem with math. Yeah, probably gonna read in the history book. You see what I'm saying? Thank you for your time, and now we go to the next question. Thank you, man. Thank you for your time, and don't forget to like, subscribe, and share only if you think it deserves the credits. And you have learned from me, tag, leave the comments. Don't forget to subscribe. Thank you.